Yes, I got it. I got it on my phone. I broke it publicly.
Jim was all, did you talk to Jeff?
Yeah, that was me.
Are you on the phone, Jim, now? It's Jeff. Oh, okay. Two passwords. Yeah, that's where I came back here. You're running. And there was no alarm following that, so I figured I would.
Okay, so we're back online.
Okay.
The authorities have just shown up and left and informed me that because I gave away the password in public, that the IT guy terminated our Wi-Fi connection, rightfully. And at this stage, Chip's really having some questions about whether or not we have chip orientation right on the P2D2 board. And
well,
really,
I'm wondering if maybe it was packaged like 180 degrees rotated.
Or if the packaging is off, so it's rotated inside of the case. We really aren't sure. And we have little to go on here. I'm not really sure why. Chip, do we not really have a diagram from on? Or we have an indicator on the chip that shows us where pin 1 is, right? That's all we have.
Let me go. I found a little solder short.
Okay, we're reloading Chip on our stream. We have half a dozen people who are still with us. Europeans have gone to sleep.
On Semi said that indeed they packaged it as so. Let's see here. So the date code should be like this, where pin 1 is up in the upper left corner. But
Upper left,
I'm just not
lower.
really sure because nothing is making any sense here. The chip's not responding in any way that I'd expect it to. It's really sporadic on current draw with reset. Let me get it hooked up again. I just noticed it really short, but it was only between what looks like a couple of I/O pins. So I will reconnect power here just to make sure. But I was looking at the pinout here, and it is such that if the chip were to be rotated 180 degrees, the power pins would all be of the same type. See, like this VDD pin second one in here, VDD pin second one in here, and
Guessed.
3 in, and on here,
Oh, really?
you know, this pattern repeats this way down here. So if I can get any kind of consistent, you know, current response by, you know, putting the one of those things to ground and then letting one of them go high and then forcing the other one high. But I just don't know what else to do. There's just nothing sensible so far. So let's see, I'll hook up. And then this jug, this grabber's losing its grabby here. All right.
So for those who were cut off, which is most everybody, That was partially my fault because I compromised our password on YouTube Live and the IT guy became concerned. Then he terminated our whole connection. But in doing so, he said, don't use that Wi-Fi point, use this Wi-Fi point. So we should have a brighter, stronger connection now for the streaming part of this. Apologies for that. Chip, I'm going to go return a call really quick, okay?
All right.
I'm just going to leave these guys here. There are 20 people online.
Okay, good.
We've got Lachlan, EOD Punk, Witt, Josh Donaldson, Roy's here. So. Well, now Roy's real here.
Roy here.
It's double Roy.
Hey, Roy. Hey. Right. That's right. Oh, yeah, that should work. Yeah, Roy's saying that, right, we shouldn't have to resolder the chip to determine if it's in backwards. It's true. Yeah, so that's what I'm kind of looking at now. 'Cause I don't see any kind of like current response, based on reset. That's what I mean. Yeah, I'm not seeing any indication. Right. 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 It would seem that we're not resetting it. Yeah. Okay. Right. Yes, that's what I'm doing now. Yeah, I'm going to try to ground. Going to ground. I'm trying to say X, I, which might be test. So in order to have it do anything sensible, we need to make sure it's not in JTAG test mode, right? So that would mean for sure that the crystal XI pin is grounded. It has to be grounded. So I'm going to ground that, and then I'm going to try to manipulate reset, see if we can see any kind of current change. Right, they'd have to be relocated. Oh, well, there's, let's see, what have I got? I've got, well, it wouldn't matter. That means I just have a pull up on XI or XO. I have a pull up on, I have a pull up on reset M if the chip's bonded backwards, then I really have a pull up on XO. Did you look, do you have the pinout in front of you? Okay. Here the case. I see the pattern that it's all mirrored. It's like 180 degree. There's symmetry at 180 degrees. But not symmetry, it like replicates. The whole power footprint replicates. And there's also this matter of maybe we don't have a good ground connection. Yeah, I really would like, if I had a super hot thin iron, I could poke that thing down in there and be pretty assured of wetting the chip. Yes, yeah, I could use that. Yeah. All right, I'm gonna do that. Yeah, okay, let me do that. I'll just as a thing, I'll reflow that. I'm not seeing any indication that it's being more responsive to change up the Reset, yeah, so I'm gonna try to reflow the ground. And then we'll go from there. See what it says. Hey, got this big machine. Oh yeah, okay. Okay, thanks a lot. Okay, right. All right, so are we still going, Ken?
Yeah, we got 40 viewers.
Okay. Sorry this has been such a long, boring day, guys. So there's two things we're wondering about. Maybe the chip was, bonded so that pin 1 isn't here, but it's down here. So if I look at the pinout on the chip, I never really fully realized this, but if you turn it 180 degrees, all the port 1.8 volt pins are in the same place, and all of the IO 3.3 volt power supplies are in the same place. So that would put on the crystal pads down here, that would put, this would be test and then reset. So we're going to explore that possibility. First, I'm going to try to get some really hot air to try to reflow this thing to make sure that we're really connecting to the thermal pad on the bottom of the chip. And that's going to be kind of hard. What I really need is a really hot poker to go through that hole and, have enough heat to reflow the backside of the thermal pad on the chip.
You want to put it through the oven?
I don't know if we can do it. Now, we put it through the oven, everything else is going to fall apart. I have little wires, yeah. Yeah, the wires would. Do you know how this thing works, Ken? You got all these. Oh. You might want to use this one over here. This one's better. Okay, so turn this off. Yeah. Okay. Is that thing on? Pull the trigger. Is it set or it's glowing? Yeah, it's hot. Yeah. Okay. All right. Let's see, some tweezers. So what we need is some blocks. Any size tweezers you want. All right, I'm going to start really heating this guy up. Okay, solder's starting to reflow, but it has to get really hot to get down to that pad on the chip.
Chip, what's the timeout when you run it at 12 megahertz?
It's like 100 milliseconds.
7 minutes?
Oh, but 12, it would take a little while longer, yeah. Well, there's another thing we can do. We can run run the 1.8 volts power supply through a resistor, and then monitor the voltage on the resistor. So any current change will show voltage fluctuations, and then we should be able to kind of see the ROM program running if that's working. Hey, Ken, are you still here?
He just went next door.
I'm thinking we need more heat here.
Let's see it turned up.
Oh, yeah, I'll have to just turn it way up.
How's it goes?
Okay. 950.
Start using the mounting holes, David. Thank you, Kenneth.
All right.
Okay, we got to say goodbye to one of our stars. He's got to retrieve children. So hang on. All these guys need to say thank you. You could thank him for his fine work today. Wait. Okay, things changed. How did it? Wait a minute. No, I'm not. Thank you, Kenneth.
You're welcome.
We appreciate it.
Today. Of course. Right now on the
Okay, and Chip's going to try to heat this thing up from the back and make sure really that it's grounded properly, Chip.
Yeah, that's the good thing about the pick and place stuff. Is it will be, so are you guys, how far are you, David, for running that pick and place?
They're setting up the mounting holes as fiducials. Okay, so the pick and place crew lost one of our ringers. Kenneth in the red shirt has to go home, take care of some children. He's got his hands full. He has 3 girls, so he's got better stuff to do for sure. But David is going to stick with the machine and use the mounting holes as fiducials. What did David say?
It's ready to go.
It's ready to go.
Yeah.
Where's it going?
I
Oh, okay. So he's a ways out. Right. You're half an hour out, right? Okay. Yeah, David's about half an hour out. Thank you, Kenneth. He's got to show the pick and place where the parts go and the orientation. He's working through it one step at a time. We can't rush him. Yeah, David knows prop stuff, where to set this. We'll figure it out. I'm sure he could use a number of markings on the board, preferably, like you said, more towards the center. He has a long-term relationship with this machine. They've been partners here at Parallax for, David, how many years have you been here? Yeah, for at least, I think, 12 years. Chip will be back in a minute. You guys got any questions online, the viewers, while we have this intermission? Anything you want to tell Chip, I could relay to him. Don't know, Roy. That was probably 10 years ago. No, maybe more like 13 years ago. Okay, Lachlan, you want to know what that power supply is to the left? Yeah, it is. It's an X-Tech 382260. And the one to the right is a Kenwood PW18 1.8 ohm. I don't know if that's the model number or the rating of it. Chip, Perry says, sorry he didn't call you back. He's been busy working on his house.
Oh, don't worry about it. That's all right.
Chip, what's different between this package and the next package we will get in terms of ground pad underneath?
Should be about the same, I would think.
About the same. Perry, you can ring Chip later tonight when we're done with this. He'll be driving probably home.
You know what, David? If we just had a board that had just one refloat on it, I could yeah, that's all we need. I mean, if that would go faster, that would get us something. Still on the card that she's so it's just a micro card that.
The thing is, still the standard visuals working because there aren't any on the board that use mounting holes.
Oh, yeah.
And something still doesn't work, but I found a workaround. Do you have any documentation that says like the dimensions of the package?
Yeah, at the end of our documentation.
Here. On the internet.
Let's see, I'm just going to try this.
Use a Dremel on the rear of the board, drill a hole, and drop in some solder for a good connection to pad.
Yeah, I was wondering about that, but I don't know. I need to look at a raw circuit board to make sure that we can drill through it without disrupting it.
You want to see a raw board? Oh man, it's a little hole that I'll chip.
I know. Yeah, that's. Well, if it's just all, this is a 2-layer board, right?
Yep.
Let me do that. I'm just going to drill through that thing. I'm going to put it on the milling machine and just drop a square end mill right into the back of it. And that's what I'm going to do.
You want to open up the hole?
Yeah. I'll use an end mill and I'm just going to drill it down.
We'll go with you. Hopefully we don't lose things in the machine shop. Well, starting to wonder if situation here is maybe the ground connection on the back of the board. So we're going to
All right, where's the knee?
get an 1/8 inch end mill.
Yeah. Should be okay. In night, when we finish the basic stamp 2, it's a Taiwanese Bridgeport copy. Paid $39.99 for this thing new. But we've learned to machine on it.
We have an 1/8 inch end. You straight for the middle.
Well, I want to try to get it. We're not going to get it perfectly.
This is the board that has the chip mounted, right? And try to control the Z. Well, here, let's get the right thing. Parallels.
Temporary thing. Shows like this. Yeah.
All right.
Set up the lights and I'll play it like
Oh, here's parallels. I found them.
I don't need them. Okay, you got
Okay. What chip? Here, I know. Here, little babies.
Okay.
Okay.
Is this?
You guys, maybe you can let me know.
Can they? Don't I have some real parallels?
Or here, pick some that are taller then.
Okay. Some that have been used. Yeah, we want really tall ones.
Okay. Here, these are the really too big though.
No. This will be fine.
Okay. Now we're messing with Kenneth's tools. Good thing he left. So now we got some parallels. Now we can make sure the board is flat. The original propeller, when it was brought up, well, we actually had a focused ion beam and an E-beam prober next door, and it didn't work. And over a 2-day period, Chip did surgery on it to find the issue. What was the problem, Chip? Back then?
The fib?
Yeah, no, with the you did the surgery.
Plugged the parasitics back in, then reran the simulations, and it looked like what I saw on that was actually the ion beam prober.
Okay, this has control, so you're gonna have to go old style.
Yeah, we're just gonna. Where's air?
Compressed air off to my. Looking for compressed air right now.
It's okay. We got a square in now. We're just gonna drop it. It's hard to tell if we're already into the chip. It looks like we might be. Where? Right, this is where's the airline?
I think you could usually plug. Here's one. This one right here might work.
Oh, okay, yeah. All right.
Good, Chip.
Okay, so a little bit more. That's still FR4. Are we to the metal yet? I see some of you.
I do.
All right, so let's drop the knee here.
Okay, now we're gonna go load that up with solder.
Yeah, look.
Did you hit the chip?
I don't know.
Oh, you're right there. It looks like you hit at least the package.
Yeah, I don't know.
Yeah.
Let's solder it and find out. We'll have some more
Okay.
in a few minutes.
I'll hurry David along. See how he's doing.
Whoa.
Want to load it up now? What do you think? Did you go through it?
Oh, you know what? Well, let's see. I think. Let me scratch it. I think we might have stopped just at the right time.
Okay, power supply is getting low on this, so I'm going to return here to this side of the room, plug in my power supply. And we're gonna load that hole with solder. Really, we're not sure if we ever even got the package grounded. And David's still pressing along with the pick and place. So Andrew, no, we have more chips than that. I think we had about 10 chips in that pack, 10 chips. So we're not out of, yeah, 10 chips. So we're not out of parts yet. We can afford to do a little bit of milling on our packages. Yes, Jack. On Semi, I did do some testing of the chips. And hey, Chip, can you describe what On did with the chips?
So they checked all their own logic out. So
On checks their own logic, but they don't program it, right? Of course, they didn't load a program.
no,
How do they make the chip generate a response for their testers?
well they have about 15% of the circuitry in the chip is their own test stuff that we don't really know about.
Ah, okay, that's it.
So they put the chip in test mode by pulling test hide, and then they have a conversation with it. And they have about 15 channels, maybe 25 channels of JTAG they can run in parallel.
What's the space consumption on the die for all that?
About 15% of the
So-
logic.
I don't know if you guys cut all that, but about 15% of the die's logic space is for On Semi to do their tests. And those tests were mostly successful, right?
Yeah.
But they didn't try to put it into a programming mode like we are now. My understanding is this is kind of a unique chip
And do you have a-
for the way
do you
they
have like a dental
operate.
kit?
What do you need?
A dental kit
We do.
to scratch it.
Okay, looking for dental tools. Red toolbox up top. I'll go check the machine shop.
I got it right here.
Okay.
Here's some things.
So do you want me to hold up the heat gun, or how do you do this?
Well, I'm just trying to figure out if I drill too far or not. I'm looking at the profiles vias.
All right, so Chip's trying to figure out if we milled past the ground plane of the chip and all the way into the die. I guess this is one of those times we could use an X-ray, right?
Not really.
Does that help us on-
You know what? I want to get that bit and just kind of spin it in my fingers and see if I can drill a little further down.
Okay, so Chip's going back to the mill room, and since the video drops in the back, we'll go talk to David and give him a little bit of encouragement. He could Probably use a break from all this. Let's see how he's doing. Looks like he's eating a candy bar, so that's a good sign. Let's go talk to David. Looks like he's describing the parts in detail now to the pick and place machine. What do you think, Chip?
I don't know. We're just gonna fill it up. I think we might have gotten down to the back side of the metal. P2. It's not taking solder. That's making me think that maybe we still have more FR4 to go through. Yeah, I bet we do. I need to mill it a little bit more.
Do you want to put calipers on the board first, Jeff? Put calipers on the board and then set the end mill on the edge of the board so you know.
I'm just gonna go with like making it go by feel.
Do you want a zero dial indicator though? We have them.
I just want to look for any metallic dust.
Okay, probably going to be losing some of you guys right now. Sorry about that. Is a zero.
There, look.
Okay, let's see what we got.
Now
Show us.
we've hit the metal. See, it's all shiny.
Yeah,
So that should be the ground pad. So
that
now
looks really gnarly.
I should be able to reflow that. Yeah, it's got right into the copper.
Okay, so the mill pad right up to the surface. Okay, we got to stay put here and plug in power, so I'm not going to be as mobile for a little while. Patience is appreciated. Blackman, I don't know how deep that hole was. Chip did it so quick, I couldn't get any measurement tools in his face. That hole just made itself. Yeah, Heater, it was animal. It was primitive. Last time we had a focused ion beam and an E-beam prober to get Prop 1 working. This time we're using a manual milling machine. You guys got any questions for Chip or for David? Need some hacker music. What's hacker music? Hacker music. Oh.
All right. Done. copper was not wetting the solder.
Hacker music while you do this. We got some hacker music for intermission here. What'd you figure out, Chip?
So I don't know. I don't know that I didn't damage anything, but we got down to the copper ground pad below the die, and I could see the copper exposed, but it was not. It was just immiscible with solder, so I had to. Whatever that metal was, it was not wetting solder, so I had to fill up the hole.
Oh my
And
gosh.
just let gravity kind of cave it in contact with the metal on the bottom. So this is, we should have just put some paste down when we first did this thing.
Yeah.
Anyway, I'm going to rinse this off now and try it out.
Maybe I should switch. Or maybe they're switching to Ram trucks than ever before.
Okay, Chip's gonna go take that for a wash, then we're gonna go back to the regular routine, hook it up, try to program it, etc.
Now we'll see if we have any different kind of current response. Oh, wait a minute.
Okay, let's get a closer look at this.
I think I destroyed it.
It's wrecked.
It's gone into current protection. Let's see. 3.3 volts okay, but the core supply is now clamping. It's not getting past 80 millivolts. So I think this one's toast. So this board's done.
$700,000.
Yeah. Or pesos maybe. Let's see. David, how far are you from reflowing one of these things?
Not too far. You can where it becomes flash, and then they tell what your color looks like, and then I do a test, make sure that the orientation's right.
All right. What if we just did this? Yeah, that's just clamping.
Any doubts about that ground plane properly reflowing on those boards? Okay. Not a problem, prop stuff. Bummer. Well,
Okay, so this is toast, but I want to keep this because it has our
it's very
kind of
expensive.
wiring pattern on it.
It's also very expensive jewelry. Maybe we should turn it into jewelry.
I don't think, the way the whole thing acted, it was never clear if the whole thing was even conducting current. I'm trying to remember if we saw current draw both on the 1.8 and the 3.3 volt supply. If so, that would indicate that there was some ground conduction. But I don't know. What we could do next time. Oh, you know what we got to do? Okay, David. Where's the circuit? I just need one.
Right, yeah.
No, I mean, oh, this is another one you just gave me? Okay, so what we could do, let's just do this. We're going to take another board. We're going to drill out the center.
Okay, yeah.
So we're going to have a nice...
That's what prop stuff suggested before
Yeah.
it goes on the pick and place.
Well, I'll just hand solder.
Okay. All right. So you're going to mount a propeller on there on your own by hand?
Yeah.
Okay.
Pretty fast.
Okay, so Chip is going to drill a hole in there on a bare board. Now we're getting low on boards. Boards with limiting factor here. David has about 4. Chip's moving on to number 2. So he's going to take a bare PCB, drill a hole in it, and then we know we can solder the bottom of the chip properly. And who knows, we might, I think maybe it would have been a good idea if we built some boards before this, but we've been so busy around here. We should have put David on maybe on a PCB design. We'll be okay. Chip likes really basic boards that have only the absolute minimal stuff, not even power supply for this kind of thing. He likes to eliminate every possible unknown. So he's coming back. It's got a hole in the board.
Right.
How'd that go?
Good.
Want to show it really quick in front of the
Yeah,
video?
I got to poke this little flap of metal out of the way.
Just a little bit of cleaning.
Yeah,
Chip,
so
is it
now-
possible to unsolder the IC off
Now
the
we
other
have a
one?
nice hole that we can easily get an iron into to,
Yeah.
solder the backside.
Now, is the raised part of that from milling it going to cause the chip not to sit flat?
What?
The raised part of that, when you drove the end mill through it, didn't it raise up the other side?
No,
Okay.
I didn't. It left a little flashing, but nothing to worry about.
We do have a deburring tool.
Yeah, we're
Do you want it?
well.
It's a round Noga blue handled Japanese tool.
All right, so
Deburr. The crowdsourcing wants you to deburr.
it's okay. It's clean.
No, deburr removes the ridge around the hole so that it's flat and smooth.
I drilled down.
But did you drill through the side where you're mounting
I
components?
don't know. Let's get a little 45-degree little thing and spin it.
Okay, no Dremel. No. We just need it. We have a tool for this. I'll be right back. You guys entertain yourself. I'll show you where it's. This is cool.
Okay. Back. So I'm going to take another chip. Where's the chip there? Okay, well let's just do that. Let's just get a stencil in there. You know what? And then, I can place it. Yeah, don't worry about it. Just give me a chip. I'll do it. It's not that hard. Where's the chip at?
Okay, so we found the right deburr tool.
Okay, new chip.
That's the tool. Ding. That's what he needed.
All right, well, 16 by 16. Again, again.
Okay, guys.
Yeah, the body's 14 by 14.
So Chip's gonna solder that chip on. I assume you guys want to hang out because you're having such a great time.
I think it's 25.
Nobody's bored yet.
Well, the body's 14 by
James
20.
Sales and Jill was 20% off of entire orders for
Um,
Christmas.
Okay.
No. Well, these are blob
I
tops.
will
They're not
qualify that with regularly priced items.
Yes.
Because
And it might just be the coupon code's not effective. It may not work.
I think they're manually applying this stuff.
Okay.
When I come in, it wasn't just that.
All right.
So that's what Sean's telling us. You could follow up with sales. That'd be fantastic. Could you make it some orders right now because of this? And we could do how to handle them.
All
So
right.
there's up to 100 people in there.
Oh.
That's what it was scheduled for.
So it's up there. He's up there.
No.
We would have to re-disable it. We could tell him we will re-enable it tomorrow morning. Okay. And I'll make sure it goes. Okay, so you guys want to go over and watch Chip solder this?
boring.
Okay, he says it's boring. Um, I got some new theme music. Someone named that song. You can do it, Chip. Don't be down. There's no need to be unhappy. Let's get a closer look at this. Okay, taking you guys for a walk here. How's soldering going?
Great. It's really moving along now. Just kind of pinning the corners down. Then I'll reflow more.
That looks good.
All right. Excuse
Put you
me.
guys in there for a bit.
There you go.
So, without burning myself.
All right, now I got to add a little solder. Wait, make sure we get all the edges.
And you're just using the solder on the pads, Chip?
Now I'm going to add a little bit. The super fine. Oh. Okay, now we're going to.
Okay, we're going to let him be for that for the time being. Maybe we'll do a checkup on David. How does that sound? David, how's it going here?
Good, just about to do it.
Just about ready to do a test? This will be good entertainment. There's the lone P2D2. Whoops, and off it went. David just ejected it. Careful there. I'm not sure what David's doing right now, but he's retrieving a board out of the back side. Oh, he's getting ready to do an auto feed. So we'll do the send off here. I have a feeling we're going to say bon voyage to this board in a minute. Hopefully this doesn't look like an episode of Gilligan's Island. David's getting a better look. Oh, it's too small for the grabber. Hey, something's happening. Nozzle pickup, part retrieving, air thrown. Ooh. Stencil. Stencil. There you go.
David, how hot is this soldering iron supposed to be?
How hot? I think 750 is what they usually have it, right?
It'd be about the same temperature as the Boeing part. So the 700s, like 7,
So-
750.
Hang on, Chip. Which number are you on here? Oh yeah, you're on this one. You're on the Ursa. Yeah, you're at 752. It's about what David asked. So the stencil. You guys asked about the stencil. Let's get a close look at it. P2D2. Whoops. Right there. So he would have manually pasted. I hear a pick and place going again. Let's go get a look. But an error was thrown. These errors mean different things than they say. As he just clears the errors.
One of these parts is stuck in the same.
Ah, yeah. This is the problem with these little short tape parts, cut tape.
That's good for the parts in it.
Oh, that part was not feeding. Oh. Is that the SRAM?
They're flash.
Flash?
Not enough of them in there.
That one's going a little bit cockeyed.
Yeah.
He knows. What's up with the tin foil on the soldering station? I was wondering that myself. I don't know.
Oh, that's just it's a kind of a. Oh yeah, I don't know.
Just to keep it screwed in. It looks like it's actually tape, not tin foil. Well, while they do that, I could show you guys something else that's coming soon. This is kind of interesting for small children everywhere. This is another robot board for the microbit. And we're calling this the Cyberbot. So if you're familiar with the microbit, we are producing, at the request of many customers, a robot controller for it. So this will sit on top of our Bobot chassis, just like the Arduino and the Propeller activity board have. And what's unique about this is it has a Propeller as a coprocessor to do all the very time deterministic type behaviors that we need with our robots. Microbit, that's a challenging task for the microbit. So we just put a propeller in there, and this solved a lot of problems for us. Simple design challenges, really. But then we wrote some firmware that has an I2C interface for the microbit. And there's a speaker on board. The microbit sits right here, and it's held captive by these pins underneath. And then you could screw in the 2 mounting holes here. This board was designed by David. So this is actually in conjunction with NYSERC, who's the National Institute Cyber Education Research Center, and they are funded by Department of Homeland Security. They're all about cyber education, and they put a lot of robots in the hands of students. And I am confident this will be the absolute most cool microbit robot because it uses components, electronic components on a breadboard, not just alligator clippy stuff. So this is coming soon. It's a big product. So I'll put that down. That's top secret internal stuff. Yeah, I thought you'd like that edge connector too. If I had a microbit here, I could show you how it fits in. But you get the idea. It slides right under the board. Microbit has this LED array on the top of it, which you'll get to see here. Some challenges with it. The online Python editor does not have a good terminal system for us to use, and we rely on that for serial data, but that's coming, and we're part of the creation and contributing to that project. So that's the only top secret thing I can show you at the moment. Yep, we're gonna level those kids up.
Okay, look.
What do you got?
So I got this thing soldered now, nice big hole in the back.
You gonna load it?
So now we're gonna try to solder that big hole.
Need the flux?
Yeah, lots of
Okay, you
flux
guys have any input for Chip? He's going in here on Propeller 2, number 2. Getting ready to solder it down. I already soldered it down. Now he's ready to add
now the
solder to the ground
let's see.
plane.
Huh.
Hot, hot, hot.
We're having the same problem where the pad just seems
It's not taking it.
it's not wetting.
Is it just repelling it?
Maybe we're not getting enough heat on it. I don't know.
It's probably not hot enough. Okay, Chip's going to finish that up in a minute. Chip, is it taking solder?
Oh,
It's not?
oh.
Trouble getting the bottom of the chip to solder.
Well, I'll take some.
It's taking a little bit. Well, we have the Aussies here live. Okay, I'm going to return you guys back here to the power supply, and under the assumption that Chip's going to be coming this way in a few minutes for more programming. So, plug this back in. In that song. For a pre-Propeller 2, name that song. No takers. Do we know Andre Lamothe? No. Would anybody claim him as a friend? Of course we would. Andre Lamothe is a wonderful character. He's definitely a person we enjoy working with, and he's creative. He writes really well. He did most of the original video documentation for the Propeller 1, and I think we worked with him for maybe 14, 15 years on and off. Well, let's see, maybe a little bit of clarinet music would be appropriate now. That's my clarinet. That is actually me. But I have no timing. Ah, very good. Lachlan, your free P2 is in the mail. Okay, I'll give you another one then. You guys are pretty good at identifying songs. What's this one? Come on, name that song. Shouldn't take more than a few notes. It's kind of a sad song. Yes, a working P2, Jeff. Jeff, when are you coming back with more food? Ooh, heater, busted that. Acker Bilk was famous in the UK, wasn't he? What time does the pizza show up? Stranger on the Shore. You guys want to hear Chip play the piano? That's good entertainment. Let's see if I can find that. Jim. No, it's not. Okay, this is Chip. Name this song. And we'll give you a trip to... Peter won't know this one, nor will Lachlan. Come on, name that song. Oh, you guys are taking an awful long time. No, Lachlan? You're a few states away, but that's good. Maybe this part will give it away. Ooh, Kenny gets it right. Good job, Publison. You're going 2 for 2. Okay, how about something a little more appropriate for what's going on?
For many of us,
Chip, how's it looking over there? The savages are getting restless. It's going.
just sit right back and you'll hear a tale of a fateful trip that started from this tropic point aboard this tiny ship. The mate was a mighty sailing man, skipper brave and sure. 5 passengers set sail that day for a 3-hour tour.
Oh, well, we've given away all the propellers now. I know, Roy. We might get knocked offline. You're right. We don't want to do that. That would be a problem. So, go get a little more. Nah, not here, Lachlan. I'll go get a little more detail from Chip. This is what we're looking at over there right now. It's a nice soldering job. How's that? It's pretty good, right? David Kerr just groaned about something. Some kind of discovery. So Chip's just getting this guy tacked down. We're going to come back over here with another minimalist, no power supply, prop plug only programming attempt. Chip, do you need some more 4-pin headers?
Yeah, I'll need 2 more.
What else are we going to need?
Just some wire, which I have.
Wired? Okay. I'm going to go get some prop plug headers. You guys stay put.
There's some in the back here.
Go back here.
Yeah.
Okay. That. Okay. Okay. Okay, we lost Heater. I think his Surface Pro computer blew up on him. There are fume extractors over there, but not on the Vision, the Mantis scope. But I don't know if Chip's using them. He's not, his exposure to this is pretty minimal. Doesn't spend a lot of time soldering. Color 2. I think the outcome is going to be pretty good here, based on the testing that was done up to this point. Once we know we have a working circuit board. That what you see to be a hose is like a bellow that allows you to bend the head of the scope around, so you can place it right over your part. So if you want a closer look at it, we can go look if you want. How's your progress, Chip? Okay, so the number of PCBs we started with 6, which showed up from Hublison, I believe, from Peter. And we have already consumed one of them. Chip's on the second one, and David has 4 that are possibly destined for the pick and place machine. Although the current thinking is we will build just one board to completion, send it through the reflow, and then try it out. What is that microscope? I thought you'd gone to bed already, Peter. I think the brand is Mantis. I don't know. That's a Mantis Compact from Vision Engineering. Yeah. Okay, it looks like we're losing another European to bed. So Bojan and Heater are both retiring. Thanks you guys for your support. Oh, no, Heater's staying up. Guess the pub is still open. There are, in total, 45 people on this planet that prefer watching Parallax over the Ford Kavanaugh hearing and national news. That's a really good ratio. But this is definitely worth watching. And if you've been as close to this as Chip has, and many of the builders on the forums who've contributed, and to the Parallax team, this time is when we'll stay up until we see this work or not work and figure out what's up with it. Because there's a tremendous amount of energy in this project, I can't begin to tell you. So there's approximately 13 years of design time with some breaks in between. Oh, David's got the machine moving. We'll just turn this a little bit towards him. 13 years of design time, one solid failed attempt, and several false starts. It was a learning process for Chip. He learned a lot about Verilog and really the analog stuff, but he's very good at analog. He learned a lot about chip design through this process. So it takes time when one person or a very small team does it all on their own. But to put it in perspective, most of his kids, and the oldest one is 13, have yet to see him complete a major engineering project. So this is really, really important we get this done. And should there be a problem, we just go back, make a rev, do it again. Chip is always calm. He showed up here during a DEF CON badge build when we were having some trouble, and we had a bunch of badges that were blowing up. Helped us sort things out really quickly. It was a buck boost regulator problem. Hey Andy, how's the webinar?
Oh, it went pretty good.
Cool.
Pretty well.
Andy just walked through. He had a webinar today for college instructors. And how many people viewed it?
Looks like we had 6 attendees.
6.
So it was not
Yeah, it's
as
low,
well
but
attended as some of the other ones.
we will YouTube it. And it'll
Yeah.
live forever.
Yes.
But you had 3 good.
Including my stuttering when my teleprompter malfunctioned at the beginning.
This stuff never works right.
Yeah.
So we're just still trying to get a P2 up and running.
Okay.
Not sure of the exact problem. Maybe ground connections between the chip and the board. Seems to be one. We had some issues with the prop plug circuitry. Power consumption looked right, but the chip just wouldn't program and identify
Okay.
in Peanut. So Chip's putting another one on a board right now, and David is trying to pick and place a few.
Good. We're still working on this. We don't know if it's working yet.
Yeah, and in regards to P1, P1 still gives me plenty to work with and many other people too. But P1 was done totally in schematic design and then fabricated from schematic. And then the open source release was done by using Verilog from the schematic, I believe. So yeah, P1's not over, and P1 is going to be a top product of ours for as long as Parallax exists. Code developer wants to know if it's for sale. Well, no. We all hope for that at some point. We're a ways out still, although timelines change dramatically when you get working chips.
Right.
Yeah, people are still using a lot of P1s in their projects. Let's see, we have them in some renewable energy projects, some number of robotic products actually, and one of the largest probably is the Scribbler 3 robot, and the Scribbler 2 had a propeller one in it. There's a couple like point of sale systems. A number of interesting inventions too. Also, guten Abend, Code Developer. Es ist nett zu kennenlernen Ihnen. CubeSats, yes, we do. Jeff might know, he's on right now. There has been a CubeSat and a few near space projects. If you research Paul Verhaeg, I think. Ja, auch Code Developer. Ich war ein Gaststudent in 1986 im Freiburg im Breisgau, ein Gymnasiumstudent. Oh, okay, and here's another project being used in a printer.
Do you have like any little
What do you need?
brush?
Epoxy type brushes?
Well, there's little brushes for like really into stuff with alcohol.
Let's see.
Oh, thank you.
Yeah, so some military applications, a couple of those. How's it looking, Chip?
That's looking all right.
Oh, a laser-based SLA. So let's see, my latest use of the P1, I shall show you.
Where'd that piece of tape go with all this stuff? Yeah, it's like the tape and all this stuff belonged on it, all this calculators.
Here's my latest use of the P1. You'll see it in a moment. It's a metronome. And this was my first use of the Propeller 1 in a way that I really needed deterministic timing. Here's another one of my projects with the Propeller 1. He says, "Come and get your meat. I butchered it myself." This particular doll lost a right arm in a quadcopter accident out back. And then Jill Ogle's internet-controlled robot shot fire at it and turned its hair into a melted mess. So what all would you like to take a look at while Chip prepares this? Should we check up on David? On the pick and place? Maybe Jeff will be bringing us a pizza in a few minutes. I'll show you another project I'm working on with the P1. I wish you guys had video control as well, so we could tour people's shops or something. I'm Ken Gracie. This is a project I'm working on. You may have seen this too. This is a robotic boat. Try to get this with the right focus so you can see it. And I'm programming this entirely in Blackdrop with GPS to do waypoint navigation. And this boat is going to be able to navigate Lake Tahoe, which is 29 miles by 12 miles, and collect surface water temperatures, among other things. And so this would have a processor for GPS, and then 2 for ESCs. It's a pretty substantial boat. Weighs about 40 pounds. These are big waves that stay 2 feet or so. There's a view on the boat. But I haven't finished this project yet. Still has work to do. But the idea here is to show the power of Blockly Prop, because it has all the commands I need to do this project. I can give you guys a tour of the office while Chip works. Who wants to see a tour? Raise your hand if you want a tour. Chip, how long do you think it'll be before you're attempting a program download?
Probably 20 minutes.
20 minutes? Oh, the badge. You want a tour? Okay. So, Chip, people want to go on a tour.
All right.
So maybe I'll take them on a tour?
Yeah, go
All right, let's go do a tour. I think I have enough power supply. Let me just check that. I'm at, yeah, 18%. So we'll do a 10 tour. Okay. We're gonna busy and sick on this tour. Just gonna apologize to you right now, okay? We're gonna start in the front of the office. So we're gonna get out of to give you a proper perspective on the whole place. It is probably after our Pacific time office area. Well, I know, Roy, but they wanted a tour, so I'm giving them a tour. Okay. Here's our top right here. That's Chantel. And most people are gone, so we won't be stopping to meet anybody. So we're passing human resources, Stephanie's area. This is where Miguel does tech support. Some quadcopters. He's got an Arlo robot. Here's our project table for our internal hackathons. And over here's another project space. This is where I put some of the stuff I'm working on. These are all XB controlled WS2812. And some Disney animation characters. Yeah, I know, Roy. I lost some people. Yep, sorry. It's a server room over there. I won't bother. So the manufacturing begins here. This would be the CNC router. This is a Haas SR100. Oh, what's that big robot? This is my hybrid robot. This is one of my original bots, and has a gas engine connected to an alternator, and it charges batteries, which are underneath it. And then it runs, of course, on electric power. However, it was recently converted by Kenneth, the machinist, with all those tattoos. What would this be for? So this thing does a wonderful job of shooting 12-foot flames at this point. Anyway, the router, this is a Haas SR100. It's currently milling some big robot parts for the Arlo. Those look like top decks. Oh, Heater's asking about things you could see on Google Earth, which would be the 555 timer circuit in the back. And then just kind of passing through into the machine area. Lots of little parts and projects that we have going on. Now we're in the CNC mill room, so Wi-Fi may become a problem. We have two Haas CNC milling machines. These make everything from sensor mounts to motor mount and wheel kits to quadcopter booms. These are quadcopter landing gear. And now we'll head into the production space. And I'll show you the shipping too. I don't know about Wi-Fi, so ship's still here. Okay. It's manufacturing right now. We're in the middle of a Propeller activity board build. Yeah, if you need some Eddie parts, just drop us a message. We'll get them to you. So these boards were just stuffed, and they're ready to head into the ACE selective solder machine, which is like, it's really a 3-axis CNC machine, and it's a teachable CNC interface where you take the solder nozzle down there around to different points on the board. And then using this, actually it's a Mach 3 open source software program, we train that what to do. And it's the coolest programming interface I've ever seen with CNC. And it's definitely warm in here because David's had the oven on most of the day now. Over here is a new product which you've seen from us. This is the Badge WX. These are really, really going well. There's the tester for it. Also here we have our washing machine. Okay, so we could bake cookies over there, and we can do the dishes here. This is a custom saw we've made for cutting apart basic stamp boards. Still have a lot of basic stamps going on. Environmental test chamber. We'll come back and talk to David. I don't need to bug him right now. Let's go over and take a look at the shipping area. Okay, so Parallax has 2 warehouses. Are you guys still with me? Looks like we have 45 viewers. Okay, this would be the shipping area, so I'll try to turn around and give you a proper perspective of it. By the way, we're having a sale on Propeller 1 chips. How many do you need? Just look at these beauties. Just nothing wrong here. Just move right along. Oh yeah, there are lasers. I passed the lasers. I didn't stop there. Anyway, so we pull from this area for the orders. You know, Doggy Doc can fix the pins. And then we ship them out every day. UPS, USPS, kind of interesting. Lately, it's been a lot of big school orders. I know you guys have heard me on the forums talk about the importance of education for the Propeller 2. And by that, I mean the educational market. Without them, there would be no Propeller 1 or 2, really. They are a big part of our customer base. This just came out. This is the telepresence robot. Roy has one of these online. And Make Magazine had a pretty big online build today. Like this robot, probably because of the whole Raspberry Pi integration. And there are a few oldie but goodies around here, like this kit, which has Andy Lindsay's awesome book in it. Yeah, this is still, I think, one of the best educational tutorials available on simple microcontroller programming. S3 robots. And then we move into warehouse 2. So over here would be our large amounts of inventory. Hopefully I still have you guys online. No one seems to be dropping. But things you would find over here would be everything from battery boxes to robot parts. Oh, this is all chassis. Each one of these is, I don't know, probably 100 complete chassis setups. And stuff like this, which would be, what's in here? I don't know, too deep to dig. Robot motors for the Scribbler 3. And then here we have everything from PCBs that we get to Scribbler robots. Some things from China, and oh boy, what a story. I could tell you about that these days. These tariffs are hitting us hard, and they're going to hit you hard, unfortunately, too. And if we still have stream, looks like we might even be able to head through the other side of the office quickly, where we will have Propeller Expo. I'll watch the user count, see if people drop. So this is our kind of engineering writing side of the office. And Miss Annie Lindsay.
Hello.
We're taking an intermission from P2 while Chip solders up another board.
Yeah, so I have.
You're watching us too.
Yeah, it looks like there's a little bit of delay between. Yeah, the other one, I'm on a webinar where.
Oh, you're watching Let's Robot?
Yeah, Let's Robot is doing a
Oh,
parallaxy
cool.
with the activity bot in it.
Nice. If you haven't gone to this, you need to check out Let's Robot TV. Go online and make an account, and you can drive around robots.
One other thing.
Yeah.
If I go to Let's Robot TV, since Roy's on there, I think we should mention that if we go to the main Let's Robot TV site, you'll get a robot. But if you scroll down, here is
other adaptations of it, huh?
Yeah. So this is Roy's, you can click buttons to hit the various keys on the xylophone.
Wow. Is that online right now?
Well, let's find out. I'll unplug the. Okay, so hopefully
It works. Yeah, we just don't have the audio.
Yeah.
Oh, that is cool. Nicely done. He's holding out on us.
Yeah, that's pretty amazing
You know,
stuff. So it
he's-
looks like maybe he's playing because it looks like a pro is working on it
Yeah.
right now.
That is cool.
Yeah, so that's an internet-controlled xylophone, which is
Great use of it.
yes, an adaptation to the Parallaxy internet-controlled activity bot.
You could bring that to an expo.
Yeah, definitely.
Okay, we're gonna head back and find Chip. Okay, things are gonna get dizzy now. We're gonna move fast. Sorry, guys. Everybody, thank you for your patience. Moving